Okay, so this is the expressions chapter from my book, Overcoming Digital SAT Math. So it's been updated for the digital version. It's very similar to the original version. I changed the numbers and stuff for the problems that I kept like the same. And I also added a little bit and like changed some phrasing if needed based off of what I saw were some updates, but really it's practically the same thing. It's just kind of formatted differently. And then there's basically just like a little bit more trigonometry and geometry. So anyway, and also like the word problems are less like annoying. So let's go to number 1 here. So a company manufactures and sells microwaves. The cost to produce X microwaves is given by this expression. Okay, the selling price is this expression. If the company wants to maximize the profit, which of the following expressions represents the profit when X microwaves are produced and sold? So right away, I just see that this is the selling price and this is the cost. So if I want profit, it would be like what they sell it for minus the cost to make it. So I'm essentially doing this minus this. So that's what I'm gonna write. Now remember, I'm subtracting all of this on the bottom. So I'm not just subtracting 3x squared, I also have to subtract negative 7x and I have to subtract 4. So keep that in mind. So when I do this, when I do the subtraction here, I'm going to get 3x squared, negative 4x minus negative 7x, minus and minus is plus. So then that becomes plus 3x. And then negative 3 minus 4 is going to become negative 7. So the correct answer here would be B. And for this next one, it's just asking for the equivalent expression. So remember, whenever you see numbers pressed against parentheses, then that indicates to you on these exams that you should be doing distributive property. Like you see how that 3 is pressed up against the parentheses. So we're going to distribute that 3 to each of the terms inside the parentheses. So 3 times 6x is going to be 18x. And then 3 times negative 5 is going to be negative 15. And then we have plus 7 just hanging off to the side here. Now we're going to combine our like terms of negative 15 plus 7. So it's going to give us negative 8. So it becomes 18x minus 8a. Now for the next one, this is a great example of how you can use the answer choices to help you on these exams. So the answer choices, if I look at the answer choices, it looks like they're factoring something out, like the greatest common factor is what you usually start factoring out. So then what I'm gonna do is I'm gonna say, okay, based off of these answers, I'm gonna see what's the greatest common factor between these two. I'm gonna factor that out. So I'm gonna I like to look at each of the things individually, like the 5x, the y, when I'm asking myself what's the greatest common factor. So that's what I'm gonna do. So between the 5s, I see 5 is the greatest thing that they have in common as a factor. So 5 is gonna be taken out with the greatest common factor. For the x's, x would be the greatest common factor because x can go into x and it can go into x squared. And then for the y's, the greatest common factor would be just y, because y can go into y squared and it can go into y. And then that's what I'm dividing out or taking out as the greatest common factor. So when I divide that out from each of these terms, I need to ask myself, okay, what's left over? So when I take 5x times 5xy squared, that's a mouthful, divided by 5xy, what am I left with over here? Well, I'm just left with y. And then now I ask myself the same thing for this term right over here. So with minus 5x squared y, if I divide by the greatest common factor, what am I going to be left with? Well, I'm going to just be left with x. So let's see, what does this match? Well, that matches answer choice D. So now let's go to number 4. So here you can, if you want to, work with the fractions on the bottom, and you can like do this whole bottom part as if it's its own equation, and then kind of look at it with the 6 on top after if you want to, but that's gonna make your life a whole lot harder. What I would recommend doing instead is just multiplying the whole thing by a number that allows you to get rid of the denominators. So one of the easiest ways that you can do that is just look at what the greatest number is for the denominator when you have fractions involved, which in this case is 36, and just multiply the whole thing by that. So I'm going to multiply the whole thing by 36 over 36 because I want to multiply by 1 essentially. 36 over 36 remember, that's the same thing as just 1, because if we divide by 36 on top and bottom to simplify the fraction, it's just 1. So it's as if you're multiplying by 1, but you're multiplying by a number that, when you multiply, allows you to get rid of those denominators. So that's why it's helpful here. So what I'm going to do now is I'm going to multiply by 36 over 36. And then this is what I get. So this is what I get. Now, you are totally able to do like 36 times x is 36x, and then do 36 times 9 if you want to do that and figure out what that is. I'm not going to do that in my head right now. And then divide by 12, and it'll get you this 3x plus 27. You can do that. Or what I did to make my life easier was I said, okay, I'm multiplying here with fractions so I can cross cancel. So 12 goes into 12 one time, and 12 goes into 36 3 times. So then this became 3 times x plus 9, which is how I got the 3x plus 27. And I did the same thing with the x minus 6 over 36. The 36 and 36 cancel out, so I'm just left with x minus 6. So now I'm just going to combine like terms on the bottom. And when I do that, I get 216 over 4x plus 21. You'll notice I made a little typo because, like I said, I changed the numbers and I must have forgotten to change the number that was in front of x for this one. So it should be b right here. 216 over 4x plus 21. Again, this hasn't been released yet, so it'll be all fixed in the new version. Okay, and then for number 5, we're going to, again, we see that we have a number pressed up against parentheses, so we need to distribute that 2 to each of the terms inside the parentheses. So this is going to become 6x plus 8 minus 6. Now I need to combine my like terms here, so then that becomes just plus 2, so 6x plus 2a. Okay, for number 6, we have this expression, and we want to know which of these it's equivalent to. So one trick that I like to remember is with like the negative exponents, if you're just using them as if you're just using the stuff on top as factors, like there's just the a and the b part are just multiplied by each other. There's no like plus or minus something, like adding and subtracting on top and bottom. With negative exponents, you can just switch them and make them positive, but just switch the location of that term with that exponent to the bottom or the top. So for instance, like a to the negative 5, all I have to do is I can say, oh, that's just going to be a to the positive on bottom. And the same thing with b to the negative 2. That's b to the positive 2 on top. And then, or you could use the whole negative exponent rule and do all the multiplication. You're going to get that anyways, but that's just like a little trick. And then what we're going to do now is I'm going to say, okay, I don't see anything that looks exactly like that in my answer choices, and I don't see any square roots on the bottom, and there's a reason for that, because we don't like square roots on the bottom in math. So what we do to get rid of them is kind of like with that 36 over 36 thing that I did in the other problem, but with square roots. So to get rid of that square root on the bottom, I need to multiply by root a over root a, which is the same thing as 1, which is why this works and doesn't like change the value or anything. And I'm just multiplying by 1 in a way that gets rid of that bottom part, the root a, that I don't want. So now when I multiply all this, what I'm gonna get is b squared root ab over, and then this is a to the 5th times root a just cancels out to a. So this is technically to the first power, we just don't write that in math. So now if I use the product rule right there, I would get a to the 6th on the bottom, and that would be answer choice D. Now for this next one, I'm gonna ask myself, what is the greatest common factor between all of these terms? So the greatest common factor between all of these terms is going to be 3. So I can divide the top and the bottom by 3 in order to simplify this and make an equivalent expression. So 15 divided by 3 is just 5, 12x divided by 3 is just going to be 4x, and then 15x divided by 3 is just 5x. So that's B. Now for number 8, we want to find an expression that's equivalent to 24t. Now, I forget what this is called. I think it's like direct variation or something like that. I always forget like the names for things in math. I'm just erasing that 8 so you don't think it's part of the problem. But I think I'm pretty sure it's called direct variation, where like you can multiply as long as you multiply each side of the equation by the same number, you're basically good. Like you're not changing the value or anything, they're still equal to each other. Because like you're saying they're already equal, so if I do an equal thing to each side, then they should still be equal. Like if I multiply each side by something that's the same, they should still be equal to each other. So we think, how do we get 24t? Well, that means I would have to multiply t by 24. But if I do that on the left-hand side to keep this equal, I have to do that on the right-hand side. So that means that 24t would be equal to all of this once I multiply all that out. Now remember, you can always cross cancel. 8 goes into 8 one time. Ooh, I do not like how I crossed that out. It goes into 8 one time, and it goes into 24 3 times. So then we have 15p times 3, which is just 45p. And also remember, if I speak too fast in these videos, the reason I do upload them on YouTube is because you can slow down the video to like whatever speed you want, or make it go faster using that little like settings button that they have on the video. You can also change the video quality as well. If it looks like blurry on your phone, sometimes your phone tries to save data in your settings by like changing the video quality on apps like YouTube. So if you check the settings button, you can also like adjust that. Okay, so now let's go to number 9. So again, remember I told you that we do not like having square roots on the bottom. So what we do when it's not just like a square root being multiplied by something, when there's a plus or minus involved like this, is we multiply by something called the conjugate, which is basically just a fancy way of saying we multiply by that same thing on the bottom, but we're gonna make it a plus instead of a minus. Like you basically just change, if it's subtracting, you change it to plus, if it's adding, you change it to minus. That's it. And you do the same thing where it's like multiplying by the same thing on top of each other so that you're not changing the value, you're just multiplying by 1 essentially, in a way that gets rid of that radical, or square root is another thing that is a term you might be more familiar with. So let's go and now do the work over here. So this is basically saying, hey, we're going to do y squared minus 6 times y plus root 6. And then on the bottom, if you FOIL this out, it's going to be, remember, FOIL is first, outside, inside, last. That's what that stands for what you're multiplying. Whenever you have two terms plus or minus times two terms plus or minus, which is what we have here, we have to FOIL. So F stands for I multiply the first thing, so y times y, which is y squared. O stands for I multiply the outer thing, so root 6 times y, so plus root 6y. And then I stands for I multiply the inner thing, so negative root 6 times y is negative root 6y. And then L stands for last, I multiply the last things, negative root 6 times root 6, which is going to be negative 6. So now you'll see that these terms cancel out right here. And if I rewrite this, I'm just going to be left with y squared minus 6 times y plus root 6 all over y squared minus 6. Now you'll notice that cancels out with that, and we're just left with y plus root 6, which means the answer should be D. Okay, now for number 10, which of the following is equivalent to this? So I would start by taking out the greatest common factor on top and bottom. So on top, the greatest common factor is going to be 2b. And then that's going to leave us with, from this term, the negative 2b squared, that's just leaving us with a negative b squared, or sorry, negative b, not b squared, negative b on the inside. And then for the plus 2ab, if we take out or divide out the 2b, we're just left with plus a. That's an a, by the way. And then we're going to do the same thing on the bottom. Okay, what's the greatest common factor there? Well, it's going to be a. And then if I take out an a from minus a squared, I'm left with just minus a. And if I take out an a from plus ab, I'm just left with b. Now, if I were to rewrite this, so I'm going to keep the 2b and the a part the same. If I rewrite the parts in parentheses, another way of saying minus b plus a is that's just the same thing as a minus b. Because if you add a negative number to a positive number, it's the same thing as just like subtracting it. And so I can say it's just a minus b. Same thing over here. This is the same thing as b minus a. So now I see, okay, I have two, basically like whenever you have something where it's like, it's easier for people to see usually with like x and y. Like let's say I have x minus y over y minus x. Like whenever they reverse it like that with subtraction, there's a trick that you can do where you just know that this always cancels out to -1. So that's what we can do here. We can say, oh, that cancels out to -1. So then if that's -1 times 2b, 2b over a, I mean, then that's going to be negative 2b over a. So it'd be that one. And the reason like this works, if we use like the example over here with the x minus y over y minus x, why we know it's equal to -1. The reason that this works is because, like, let's say I wanted to factor out -1 on top. So like I'm taking a -1 out of x minus y. Well, in order to get back to x minus y, that -1 would have to be multiplied by -x, because -1 times -x gets you back to x. And then on the inside would have to be positive y plus y, because -1 times y would get you back to minus y. So then you would have this, essentially. And remember, at negative x plus y is the same thing as y minus x. So then these would cancel out, leaving you with just -1. So that's like the logic behind it. So for the next one, we want the sum of these expressions. Remember, sum means that we're adding these up right over here. So if I do 8xy squared plus 2xy squared, that's just 10xy squared, which they all have. If I do 4x plus -9x, that's just -5x, which they all have. And then -5 plus 6 would be +1, which they don't all have. It's just this one that has that. So it would be D. Okay, so for the next one, we want to know which one's not equivalent. I highly recommend whenever you see like words like not or except on these types of exams to circle it, because you'll be astonished by like how many people answer in the affirmative rather than like what you should not be wanting, or like what's not equivalent. Instead they put what is equivalent by accident. Even though it's in those big letters, still circle it. So I'm gonna look at this and I'm gonna see, whenever I see like stuff like this where it's like exponents to like an x power or something, it's usually asking you to rewrite the equation or expression in some way in terms of like the same base, like bases. So that's what I'm going to start doing. So like for this one, 256, I know that's the same thing as 4 to the 4th power. And then I know that 16 is the same thing as 4 to the 2nd power. So this would be just 4 to the 2x right there. And then I know when I do that, I can solve for what x is that way. So like the next step, if I were solving for x, would be like, oh, for these to be equal, that means that 4 has to equal 2x, which is what this one says already. So these have to be equivalent because that's getting essentially to that point, which is equivalent or the same exact thing as c. And then we'll see, oh, remember 4 to the 4th was the same thing as 256. So those are the same, and this is like literally written exactly the same, so those are equivalent. So that means that B must be the one that's not equivalent, and you can show that because 4 to the x, if we did 4 to the x power and we wanted to rewrite 64 as 4 to some power, that would be 4 to the 3rd power. So that means like if we were to keep solving for x, we would get x is equal to 3, which is not what we got initially for those other situations. Okay, so now let's try number 13. So here I see, again, look at the answer choices. They are basically just foiling this out and then multiplying by -4. So that's what I'm going to do. I'm going to start by foiling out this part. Remember, FOIL is the acronym that stands for what we multiply. So F, we're going to multiply the first things. 3x times 9x is going to be, and I'm going to just put the -4 out here so I don't forget it, but I'm just foiling these parts right here because you just FOIL the parts that are in the parentheses that are being multiplied by each other. So I'm going to do 3x times 9x, which is 27x, x squared, sorry, 27x squared. And then now I'm going to do O for outer, multiply the outer stuff. So that means I'm multiplying 3x times -6, which is going to be -18x. I multiply the inner stuff, 6 times 9x, which is just going to be 54x. L, multiply the last thing, so 6 times -6 is -36. So now what I need to do is I need to combine my like terms here of -18x plus 54x. And when I do that, I get this 36x right over here. And then now what I'm going to do is I'm going to distribute the -4 to each of these terms in parentheses, which means I'm just like multiplying by each of these. And that looks really ugly when I do that. Whoops, sorry. So I'm multiplying -4 times each of these terms in parentheses. So when I do -4 times 27x squared, I'm going to get -108x squared. So I know that it has to be this one just automatically. But if you kept multiplying like -4 times 36x, you would get -144x, and then -4 times -36 would be +144. Now, I want to clarify, I realized something I said with, I think it was number like 4 before. Let me check really quick on my other copy. Yeah, number 4, I said that like, oh, the trick that you use, you can multiply by like the one that's greater on the bottom. The reason you could do that with number 4 up here was because 12 and 36, like 12 goes into 36. 12 is a factor of 36. So when I should have clarified by saying like when it's a factor, like when they're both, when one of them is like a factor of the other, you can do that by multiplying by the bigger number. That's what I meant to say. I just realized that like I kind of like said that a little strangely. But here, like you couldn't just multiply by like 5, or for instance, like because 5 doesn't go into 4x and 4x doesn't go into 5, like you can't do that. So what you would do here, if you want to use that trick, is instead you would multiply by the all of the denominators if you want to do that. So you can multiply by 5 times 4x if you want to use that trick, which happens to be 20x. So you can say, oh, I'm going to multiply, instead of doing each of them individually, I'm going to multiply by 20x. And you're perfectly able to do that. And then that gets rid of your denominators once you like simplify, because like 20x times 4 is 80x. So then 80x divided by 5, you could say, oh, that's just going to be, what is that? I can't do math right now, which is 16. Okay, 16x. So then this would become 16x, and then you could do like the same thing over with the other side if you wanted to. That's one way that you could simplify these. But if you do that, you're going to get rid of the denominator for this problem, because that's the whole point of that trick, is like you're supposed to simplify them without, by getting rid of the denominator. But if you look at the answer choices, that trick would not be like a good thing to use here because they all have denominators. So you don't want to use the trick that gets rid of the denominators, if that makes sense. So what I would do instead is just do the usual like adding and subtracting fractions way, which just says, okay, even though there's a variable there, doesn't matter. We're still going to follow our same rule where we need to have the lowest common denominator. So between 5 and 4x, the lowest common denominator would be 20x. So that's the lowest number that they can both multiply to, that they have in common, that they both multiply to. So 20x is going to be on the bottom, but I can't just magically turn 5 into 20x. What did I do to get 5 to 20 to turn into 20x? Well, I had to multiply by 4x. So if I do that on the bottom, I have to do that on the top. That way I'm changing the top and the bottom by the same amount. So I'm not changing the overall value. So now I have 4 times 4x, which is 16x. And then 4x, to get to 20x, I had to multiply by 5, so I have to do the same thing on top. And that gives me 15. So now, remember when we add fractions, we keep that common denominator, that like denominator, 20x, and then we just add the numerators, sorry. So then the correct answer here should be C. So number 15, if you've done some of my other like worksheets, this is one that I like to include like whenever I do a worksheet on expressions, because it's one that literally trips up like almost every student I work with. So you might recognize this if you've done another one of my worksheets. But basically what this is you have to remember like your factoring formulas, which is on the formula sheet for this book, if you want to go back and refer to it. So basically this is the one that says, I use A and B in my book, but because we use A and B in this problem, I'm going to use X and Y instead. So basically the formula goes, if I have X squared minus Y squared, it's going to be equal to X plus Y times X minus Y. Now look at how this portion looks very similar to what we're seeing over here. Or sorry, not over here, with the answer choices is what I mean. So like over here, you see like, oh, I kind of have that, like maybe we're using this formula. Also, you can think about how the left side looks more like the question if you were to rewrite the question and say like, oh, X is equal to A minus 1. And Y could be equal to B plus 1. It's tripping me up because I use A and B in like the formula version, which is the reason I did it like this, because a lot of people like use the A and B in the formula, and the SAT and ACT like to trick you by using the letters in formulas you're used to for different purposes. So here, Y would be B plus 1 and X would be A minus 1. So if we were to replace that right here, that means like it would be X squared minus B plus 1 is Y, so that's minus Y squared. So we would say it has to be equal to x plus y times x minus y. Well, what is our x? Our x is a minus 1. So in place of x, everywhere I see an x, I'm going to put an a minus 1. And everywhere I see, a y, I'm going to put a b plus 1. So then I'm going to put plus, and then for y, b plus 1. Everywhere I see x, I'm putting a minus 1. Everywhere I see y, I'm going to put b plus 1. So this would be minus, remember, it's not just minus b, it's minus the whole thing, minus b plus 1. That's why I put it all in parentheses, so I remember to minus the whole thing. So now, when we simplify this, well, the negative 1 and plus 1 cancel out, so this is just a plus b. And then over here, we're going to have a minus 1, and then distribute that minus to each term in parentheses, so minus b minus 1. So then this is going to turn into a plus b times a minus b minus 2 over here, which is exactly what we have here for answer choice B. So like basically you try and look for stuff that like you should see a pattern. A lot of algebra is like patterns so that you're looking for that you can like manipulate to your advantage. So like here you see in like the answer choices, there's a pattern where like this kind of looks like a little bit like that. I think this is called like the difference of squares formula, something like that. This kind of looks like that with like that beginning and that ending part for B and C, and also like D also kind of looked like that too. So like maybe it has something to do with that particular pattern, that particular formula. So I'm going to try to apply it here. This would be like one of the harder questions though on the exam. Okay, for this one, we're trying to find out what the value of B is, right? And they're saying these are equivalent. So I have to think, how can I manipulate this expression to look like this other equivalent expression? Well, I see that they had to have factored out a 4 at some point. So that's what I'm going to start out by doing first. I'm going to factor out that 4. So then if I take the 4 out of this first term, that's just going to leave an x squared. If I ask myself, okay, if I'm going to divide by 4, take out the 4 essentially from this term right here, what would be left over? Well, that means I would have to have minus 1 over 144 y squared. And you can even check this because you can say, oh, if I distribute this back, if I do 4 times 1 over 144 y squared, I'm going to get this original term when I simplify. So that's another way to think about it. If you don't see the other factoring way of doing it where like you're dividing that out, you can just kind of like guess and check numbers to multiply if you need to, but that's kind of like less efficient. So now what we're going to do is we're going to say, okay, we're looking a little bit more like this equation, but we're not quite there yet. Here we have the difference of squares formula kind of thing that we just talked about in number 15. You don't really need to like memorize that formula for this one. Like it's kind of just like, I call this reverse foiling. Like I ask myself, okay, what times what when I FOIL it gets me back to this initial like expression right here. Oh, that's a terrible x. There we go. So x times x would get me to x squared, and then I have to ask myself, okay, what goes here and here that would get me to, when this like FOILs out and simplifies, get me to negative 1 over 144 y squared? Well, that would have to be plus 1 over 12 times y minus 1 over 12 times y. And you could FOIL this part out to check that you get this same expression right here, which you do. And that's another way, like you can kind of guess and check when foiling, or reverse foiling, is what I call it. And then you could FOIL it back to see if you get the same exact answer if you want to check it. But when you FOIL this out, it is going to get you back to that original expression right there. This you kind of just have to get really good at, like doing in your head. Like it's always going to be like the first numbers multiplied, like x times x, like because in FOIL, the f is for the first numbers you multiply have to get you to x squared. So like the first terms have to multiply to that number, and then like the last terms always have to multiply to this whatever's right here. But where it gets tricky is like you also have to think of the O and the I situation, the outer and the inner. So like in this case, the outer and the inner terms when you multiply would have to cancel out so that you're just left with the first and the last term when you FOIL it out. So this is like one of the harder problems. And now you see, oh, it looks a lot more like this equivalent expression right here. And we're looking for b right here. So b has to be the number that's being multiplied by y if we don't consider like the sign in front of it, which would just be 1/12. 1/12 is what's in front of the y here. 1/12 is what's in front of the y there. So the answer would be 1/12. Okay, for this one, you just have to remember, like, the biggest thing that trips people up on this one is that they forget that the minus has to apply to both the things in parentheses. So like you have to subtract 4k and you have to subtract 6 root k. So 6k minus 4k is just 2k, and then 2 root k minus 6 root k is going to be negative 4 root k. So then that's going to be b. And then number 18 is one of those reverse foiling ones. Now, technically, if like you're really bad at like the whole reverse foiling thing, or like factoring is what it's called, but I just like to call it reverse foiling, because it kind of makes more sense to me. Is if you're really bad at that, you can, but you're good at foiling, you could just foil each of the answer choices and see which of these, when you foil it, gets you back to this original expression. Which you kind of already have to do when like you're factoring in your head anyways. So I'll kind of just like show you how that works. So like if I were deciding, okay, I want to factor these out, I'm going to need numbers that or things that multiply to x squared when I foil this. So that means that there has to be an x and x here, which all of these have. And then I need numbers that multiply to the last term, negative 18. Well, all of these multiply to negative 18 because like negative 9 times positive 2, negative 6 times positive 3, like all of those are going to multiply to negative 18. So that doesn't really help me. So what I can do instead is I can actually start foiling all of these out to see, okay, well, which one's going to get me that original expression up here. Now, I usually do this in my head, but for like the purposes of this video, I'm going to do it like all out. So for answer choice A, I'm going to foil it. So the first thing times the first thing would be x squared. And then I'm going to have outer, so 2 times x, 2x. Inner, negative 9 times x is negative 9x. And then the last thing's multiplied, negative 9 times 2, negative 18. So when I simplify this and combine my like terms right here, I'm going to get x squared minus 7x minus 18, which is not what we want, so it can't be A. So now let's try B. So for B, x times x is x squared. Outer, for the O in FOIL, 9 times x. Inner, I, is negative 2 times x, so negative 2x. And then the last term is negative 2 times positive 9 is going to be negative 18. And I see right here 9x minus 2x is going to be 7x, which we don't want. So it can't be B. Well, my slashes are really bad. Okay. And then we're going to go to C. So now I'm going to FOIL it to see if I get back to that initial expression that I want. Because if it FOILs out to that, then they're equivalent expressions. So x times x is x squared. 3 times x is 3x. Negative 6 times x is negative 6x. Negative 6 times positive 3 is going to be negative 18. So this would become x squared. And then 3x minus 6x is negative 3x. And then minus 18. That is not what we want. So it has to be D. But let's just verify why. So x times x is x squared. 6 times x is 6x. Negative 3 times x is negative 3x. Negative 3 times 6 is negative 18. Combine those like terms right here of 6x minus 3x. And that's going to give us positive 3x. So it's x squared plus 3x minus 18, which is exactly what we wanted. So it is in fact D.